Hello and welcome to this video where we're going to be talking about solving exponential functions and modeling using logarithms to find very precise answers. So in this situation, we have, according to the Herald Sun, the Durham Orange Light Rail Transit Project, a 17.7-mile system, is part of each county's transit plans. The rail system could connect hospitals in Chapel Hill to Duke and NC Central Universities in Durham, and points in between with 19 stations. So we have 4 stations in Orange County, 2 in Chapel Hill, and 13 others in Durham County. The original project was estimated at $1.8 billion. The government used loans to pay for the project. At the end of the term, a lump sum of $3.3 billion was due. The additional cost was due to interest on the loans at an annual rate of 5%. How many years since the organization of the loan are the governments repaying the original loan? Solve it algebraically. So the first thing we need to do is kind of look at what is important. So some important things that were mentioned: the 3.3 where it's ending up at, the 1.8 billion that it's starting at, and a 5% increase in cost based on interest along the way. So the first thing we need to do is that, well, if I have 5% as a decimal, 5% as a decimal is going to be equal to 0.05. So that percentage was 5% is 0.05. So now let's look at the algebraic method here. So we're trying to figure out our 1.8 is our kind of our starting point. So we have 1.8, and that is being multiplied because basically we have 5% increase. So if you recall from earlier this chapter, that would be 1.05. And then we have to the power of x based on how many years it has happened. And then we're trying to see when is this going to be equal to 3.3. So as of right now, based on our knowledge of this, we would have to kind of try some different number of years. We could try 1, 2, 3, 4 years and see if we can get a number of years that would work. But we may not be able to get 3.3 exactly. So what we have to do is use logarithms in order to do this. And we're going to make it easy on ourselves and only use a common logarithm where we have a base of 10. On your graphing calculator, the log button on that is already base 10, so that's why we're choosing to use it that way. And we'll also see how that can happen in Desmo's calculator as well. So the first thing you would do in this problem would be to divide both sides by the 1.8 on the front. So I could divide by 1.8, and that would kind of cancel that out, and divide by 1.8 over here. So if we divide 3.3 by 1.8 on a calculator, you get about 1.83. So this side is equal to 1.83. And that is going to be equal to what we have left over on the left side, which is 1.05 to the power of x. So now we have a logarithm or an exponential problem here. So one option we have would be to rearrange this in terms of a logarithm. So it'd be log base 1.05 of 1.83 would equal x. The problem with that is that that's not using a base of 10. So a alternative, possibly easier method to do this would be to take a logarithm of both sides. And what that would look like is we would have basically log of everything on the left side, and then we have that equal to the log of the right side. So now if we are looking at what we have here, there is a logarithm rule where if you have an exponent where this x is, that can actually go to the front over here. So that means that we would have x and then multiplied by the log we already had there, 1.05. And that would be equal to the logarithm we have on this side as well. So we have that logarithm all set up there. And so then now, as our last step, we're just going to divide both sides by this logarithm of 1.05. So we're dividing by the log of that. And the same thing over here. And we'll use our empty space on the right-hand side there to write our final version of our answer, because we know that this would kind of cancel out, and then we end up with x left over on the left side, and then equal to the log of 1.83 being divided by the log of 1.05. So now if I wanted to solve this, so you could go to your calculator and type the log button 1.83 in closed parentheses divided by log button 1.05 in parentheses. We can also do that in Desmos. So if we take a look at that real quick, we are doing the log of 1.83 being divided by the log of 1.05. And we get an answer of 12.386, and we'll round that to about 12.39 years. And so that is our answer here. X equals 12.39 years. So if we were to do this same problem graphically, it is pretty straightforward, whether you're doing your calculator or on Desmos. So if we go back and we basically are going to take this original blue equation. So we have one side of our equation is y equals 1.8 times 1.05 to the power of x. So we can kind of see that exponential equation right there. And then the right side was just 3.3, y equals 3.3. And we are able to find that intersection point of 12.423. And that would give us our answer there. It's a little off. We did a little rounding, but we kind of, they would both round at the same thing as 12.4. It's just a little bit different. Moving on, we have each round trip ticket will cost $14. How many tickets will we need to sold? Will need to be sold to cover the original cost and the interest. So if we are looking at the total cost of 3.3 billion, we would just be doing 3.3 billion divided by 14. So if we put that in our calculator, so it comes to basically 235 million tickets by doing 3.3 billion divided by 14. So it would be quite a lot of tickets for this rail system to cover itself, for sure. So moving forward, we have some kind of similar problems, the approach as earlier. So for part A here, it's talking about the Durham County population. It starts out at 311,640, growing by 1.48%. And it's going to double to be double what this population is. So we have 311,640. And we are doing 1 plus this is decimal, so 0.0148. So 1 plus that, 0.148 to the power of x. And then we can just double our 311,000 number. And we have that equal to 623,280. So obviously, if you were to divide by 311,000 and then this 600,000 number, well, this is twice what this is. And so that means that 1.0148 is going to, power of x is just going to be equal to 2. So we just have to basically figure out the answer there. So kind of using the same strategy as earlier, we would kind of convert this to logarithms of both sides. So we'd have the log of this left side and then the log of 2 on the right side. And then our x value right here is going to move to the front. And we would basically have from that x times the log of 1.048 and equal to log of 2. And we just would divide by this logarithm. So our x value is going to be equal to the log of 2 being divided by the log of 1.0148. And so we can use back to Desmos to figure out the answer there. So we would use this over here. So we have the log of 2 being divided by the log of 1.0148. And so you can see that it would take about a little over 47 years. So we would round that to about 47.18 years. So our answer is 47.18 years. Part B is basically exactly the same, so we'll just skip it for this video right this second. So 4 is kind of just a thought problem, not really math involved. So one of the supporters of the light rail argued that the government could pay for the light rail with ticket sales alone. How reasonable do you think his argument is? So from ticket sales, we mentioned that it would end up being about 235 million different tickets. Given that the population of the whole country is only about 330 million, that would be a very large amount of people using this. So it would take a very, very long time. And I think that would kind of be enough of the argument to say that it may need more than just ticket costs to overcome that amount of money. So as far as explaining in detail to how to use these different methods, the main idea that we were looking for graphically would be to have each of the left side, which is just 150, be an equation, and then y equals 3 times 2 to the x is the other equation, and we would kind of see where they're going to intersect. And that point is going to be your answer. So algebraically, your steps would be step 1 would be dividing both sides by 3. So the end result of that would end up being 50 equal to 2 to the x. And then I would put in a log of base 10 or just logarithm of 50 is going to be equal to the log of 2 to the x. And so then the next step after that would be moving that x to the front here, since it's an exponent already. And so we can write that out as the log of 50 on the left side being unchanged. And then we have x times the log of 2. And then we would just divide both sides by the log of 2 as another example here. So we have log of 50 divided by the log of 2, giving us our final answer in this algebra problem. And depending on the test you were doing, they could have the problem set up as the answer is which of these would represent the answer. So it's important to be able to do this algebraically and know that log of 50 divided by log of 2 would be your answer. And we can go to Desmos to find the log of 50 divided by log of 2 is about 5.64 for our answer. 5.64. And so we've seen graphically, algebraically, both are legitimate ways to approach the problem. So we will approach these exponential equations in the next part of this video, where we'll take a little bit of time to walk through those steps of solving it algebraically. And you can use your graphing calculator and or Desmos to check them using graphing, using the methods we've already looked at so far in this video. We are now looking at some exponential equations that aren't attached to word problems. We are just kind of solving some equations, and we're going to be using logarithms to do it, because remember, we can solve it graphically pretty easily. So we're just going to practice using our logarithm algebra to do this. So for our first problem, 6a, we have 120 equals 3 times 5 to the power of x. So I would divide both sides by 3 first, and that means that I would have 40 is equal to 5 to the power of x. So when you are doing this, the easy way to approach it is by using log base 10. So I'm going to write them both as the log base 10 of 40, and then we have it equal to the log base 10 of 5 to the x. And so now that we have that, we can now move the x to the inside. So I now have x times the log of 5, and that is still equal to the log of 40. And now we have that, my last step would be then dividing this side and the left side by the logarithm of 5. And so this side on the right, well, I know that log of 5 divided by log of 5 is 1. So that just goes away. And so that our answer, log of 40, would equal to the log of 5 for our answer. And then we can grab our calculator right here, and we're going to do the log button 40 and log button 5 to find our answer of 2.292. Rounded to the nearest, well, thousandths, that's, well, we were supposed to do 100th, so we could just cross out the 2 and just do 2.29, rounded to the nearest 100th. So just as a side note here, what basically is happening here is something called change of base formula is sort of what we're looking at. And so if you took this logarithm here, well, that would be just rearranging it as log base 5 of 40 equals x. And then we could kind of skip to this bottom step, but it's a little bit more complicated doing it that way. So moving on to problem B. So we have a minus 3 in the end. So I have to add 3 to both sides, giving me 3.8 equal to 356 times 0.75 to the power of x. So now I would do 3.8 divided by 356. So that equals 0.0107. And that is equal to 0.75 to the power of x. So I'm going to take the logarithm of both sides and get this result here. So I kind of get just down to b to the x equals number there as far as steps go. And then you can move the x to the front. So I now have x times the logarithm of 0.75 equal to the log of 0.0107. And then I'm just dividing by log of 0.75. So I have the log of this kind of little tiny number divided by the log of 0.75. All that is equal to x. And going to our calculator, the log of 0.0107 divided by the log of 0.75 is 15.77. So that takes care of problem B. Moving to problem C, we can scoot our paper up a little bit. We have now 2.56 equal to 5.87 times 0.8 to the power of x minus 5. You'll notice we have an x minus 5 there as the difference in this problem. So the first steps by dividing by 587 is the same. So we'll write that in there. Divide by 587 on both sides. So 2.56 divided by 587 is 0.0044. 0.0044 equal to 0.8 to the power of x minus 5. So now what I basically am going to do is I'm going to take the logarithm of both sides like before. So you can see the same steps, no matter the problem, are really happening here. And just like before, we're going to move x minus 5 instead now to the front. So I now have x minus 5, and then the log of 0.8. And then we have the log of the 0.0044 still over here. And then so we're going to divide both sides by this log of 0.8, but then we're going to have one extra step happening after that. So we have that, and then underneath it, we have this log of 0.0044 divided by the log of 0.8 equal to x minus 5. So it would just be adding 5 to both sides. That's the one little extra step on the end of this problem. So it would be a plus 5 there. And we're just going to put that all into our calculator in one shot to avoid any possible mistakes. So log of 0.0044 divided by log of 0.8 plus 5 is 29.32. Rounded to the nearest hundredth. And last but not least, let's try problem D. So we have some different things happening with a minus 10 on the end and then a 2x up at the top. So now we are going to add 10 to both sides. So we have 12, 1.05 to the 2x equals 60. So then we're going to divide by 12 on both sides, and luckily we know that 60 divided by 12 is 5. So I have that after dividing both sides by 12. Now I can take the logarithm of both sides. So log of the left side, log of the right side, and we didn't change anything else. So we got that going on right there. And then we have the 2x going to the front. So now our next step is 2x times the logarithm of 1.05 equal to log of 5, like that. And then we are just dividing by 2 and by that logarithm. So the denominator on the right side is going to have both. So we are dividing by 2, and we're also dividing by log of 1.05, and divide this by log of 1.05. So we have that set up there, and notice I put brackets around the bottom, around our denominators. So in our calculator, once we kind of write out this end part here, we just have x left over, and then we have on the right side, what we're going to put in our calculator is log of 5 by itself on the top, and then 2 times the log of 1.05 on the bottom. So we have to be careful how we're going to put this in our calculator. So let's get that in front of us. So we have the logarithm of 5, and then being divided in parentheses 2 times log of 1.05, and then end parentheses, meaning our answer is 16.49. And that kind of solves our last exponential equation using logarithms. And to make sure you did this right, you could use your graphing method on Desmos or your graphing calculator to assure yourself that you've done it correctly. And that would be a good check to see if you've done it right. Remembering that you may need to prove the algebra steps here on test questions or in future problems in general. And that concludes this lesson on solving exponential equations using logarithms. Thank you for watching.